All right, so for the homework, you should be, as I talked about last time, getting a server and installing Autopsy. By the way, a lot of students, several students had trouble putting up their cloud server and told me that they got a message which Microsoft put up. I saw this also, but I thought it was because I'd already used up my account. But students are getting this message: you're not eligible for a free account. And a student said you can get this fixed by sending an email to the Microsoft support team. So hopefully that works. Let me know. I don't have free Google Cloud credit yet, but I'm hoping I'll get them by next week. So that would be another alternative. If you can't get Azure working, you could use the Google Cloud. But anyway, apparently you can, if you go to the support desk, get in, even though Microsoft for some reason doesn't include us on their default list. So let me know if people are having trouble getting into Azure. And once you have a server, then for the coming up assignments, I've got now I found a whole, because Irvin, the previous teacher that taught this, there was a whole class in Autopsy, a whole series of videos that normally cost money, but they were delivered free during the pandemic, and Irvin downloaded them and saved them. So we've got that. So that's what I put for the next couple of homework is Autopsy training videos. Now, you've got them here. These are from Brian Carrier, who is a real famous forensic examiner, wrote some very important books. So his technical excellence is great. Using Google Cloud, oh good, okay, yeah. Yeah, you can use Google Cloud for this class too. I say it'd be fine. I just haven't got my free credits yet. Anyway, so you can get videos here, and what you'll get, unzip this file, and there are 18 videos in there. And I thought these videos are pretty nice, but there's too many of them and they get sort of long. So what I decided to do is just assign the first 5 of them and make all the rest extra credit. So you can watch these, download these videos and unzip it. They'll have MP4s that should run on any operating system. And then you can watch these videos, and then there are quizzes to show that you've found these points in the video and you can collect your points. So for next week, I would say just look at the first 3 videos and take the first 2 quizzes. There's no quizzes for the first video. And then for the next week, it's more of the same. So I think the first 5 videos give you enough information to use Autopsy for what we're doing here. And you don't really need to have the other ones. But if you want to watch all the other videos, there's extra credit here. You can make a lot of extra points by doing that. If you like watching those videos. I got sort of bored watching the videos, so I didn't want to do any more. And then I just wanted to start using it. And so using Autopsy is not that hard. That's the whole point of it. And so down here in Module 5, you can start doing the real hands-on projects, and that's what I'd like to show you now. So a Rhino hunt with Autopsy is here. And this is using an old case that SANS put up in like 2005, where the idea is that the city of New Orleans has passed a law saying you cannot have rhinoceros images, which is of course just sort of a joke, but the point is that it's a way to give you a forensic challenge. And so you have a person who seized a computer and a USB key. And the computer had no hard drive, which is a nice excuse why we can have a small case that'll be easy and fast to process in the software. So all you have is a USB key and 3 network packet captures. So the first thing, and it's in this file called only 3 megabytes in size. So the first thing you have to do is download the file and verify the hash value. You'd add this program called hashcalc to your Windows machine, and then calculate the hash. This is what you always do, very important thing in forensics, to verify hash values of things. Whenever you have evidence, you store the file with the hash value, and when you make a copy, you verify the hash value to make sure that the evidence is not been corrupted in copying. So this first flag you turn in is the first few bits of the SHA-1 hash, first 2 characters of the SHA-1 hash, to prove that you've got it correctly. Once you got the zip file, you can unzip it. And since you verified the hash value of the zip archive itself, that means all the files inside it have to be intact. And there are 4 files in there. The one that matters for us right now is USB, rhinousb.dd. DD is a disk duplication program that you get with Linux, and it makes a perfect one-to-one copy of a file. So this is 243 kilobytes, and that's the exact size of the original evidence. It's not compressed or anything. These are packet captures with the log file extension instead of the more common PCAP extension, and we'll do those in the next project. So now, run Autopsy, and just as you did before, create a case and import the evidence from Rhino USB.dd. And I should have that all loaded up here. Yep, there we are. I loaded it up during the break. So this is my Windows 10. I'm running it in a local virtual machine, which, by the way, you can do that too, instead of using cloud machines if you want to. And so here we have Autopsy. And I've already loaded Rhino USB.dd, so you can see what's going on by just expanding these features in the left. So file types by extension are pretty good, and you see there are 7 images. If you click on that, here's the images appearing. And if you click one image, you'll see a preview of it down here. So this one looks like a blue-looking crocodile, and so on. So you can flip through the images and see what they look like, and that's the first thing you can do. And you'll find that some of these images are the forbidden rhinoceros images, and some of them aren't. Yeah, alligator, that's right. Alligator and crocodile, I don't know the difference. You might. Anyway, so there's the images. Now, if you go down here are deleted files, and see there's 132 deleted files. So that's, of course, where a lot of the goodies are. So if you go to the deleted files, it lists them all here, and at first they're not necessarily in any useful order. So to put them in a useful order, you can scroll all the way to the right and sort by MIME type, which I've already done here. This puts the Microsoft Word document at the top, and then the images, and then the text files under it, because there's a Microsoft Word document, a few images, and then more than 100 text files. So the Microsoft Word document is a diary, and it looks like it's got pieces of some novel in the South in it or something. If you go to text, there's text, and should be preview somewhere. That's application. Okay, I think I need application. Well, you should be able to see that file, and I've saw it before. Somehow I'm not able to see it now. I've somehow fouled up my my Autopsy. I should be able to read that diary, the applications file. What happens if I double click it? View in new window. There it is, but I wanted to see it as a Word document, which I was able to do before, and I don't know what I've done to make that stop. Well, you can read the text here, and maybe that's what I had to do. I thought I actually saw it formatted, so here's text, and I don't know if I can make that font bigger. That would sure be nice. A script. Nope. Don't suppose Control Plus would work or anything. Anyway, this has a lot of text in it. Can I export it? I probably can. That's an option. I could, for example, Control A would select it all, then Control C. This is one way to make it big. I'm sure there's some way to do it inside Autopsy, but I haven't figured it out. Let's go to Notepad. Good. And put it in here. And now I can make the format bigger. All right. There. So anyway, this has a lot of text in it, and as you read through here, there are eventually some clues you'll find in here. And so the flag you're looking for is, so here first you have to find a file for the, let me go through the flags here. The first flag is just a hash value to show that you got the, you verified the hash value of the evidence. The next flag is find an image that has a mother rhinoceros and her child. That should be pretty easy when you're going through the images. The third flag you get by reading that diary, which explains what happened to the hard drive. In that diary, they explain what happened to the hard drive, and so that's the location of the hard drive is the flag. And the fourth one, you'll find files containing an email address at MIT here. And there's an extra credit flag to find there. And to find that one, you have to explore more things back here, down here. Go into your analysis and look around for ways to find email addresses. Autopsy does have a feature to automatically find and tell you about any email addresses, because that's very important, because of course all the email addresses in your evidence file indicate places you could go look for more evidence. So that's a little bit more practice with Autopsy. And the other thing that you've got here is more working on this case with Wireshark, and that's what I want to show you. So let's get rid of this. I don't need to save that. So Wireshark, you've hopefully used it in previous classes, but if you haven't, you can use it here. It's not very hard to do the simple things we're doing here. Wireshark is used to analyze network traffic, and the other files in this Rhino case are network traffic. So you can do file open, and Rhino .log is the first packet capture and the only one we're going to use in this project. So when you open it, you see this is 6,557 packets. So there's a lot of different types of data in here, but the only two types of data we care about are telnet and FTP. So one thing to do, one easy way to analyze it, is to break it up into separate files, and that's the procedure I used here. And the project I'm talking about here is F201. So let me just bring it up here so you know where to find it. F202 part. This one here is Rhino Hunt with Wireshark. So here's the instructions. It uses the same evidence file. You open rhino.log, and now you have 6,557 packets. So the first thing we're going to do is find the telnet packets. So up here, you put telnet in the display filter. Just type in telnet, and by the way, when you type in something that's not a recognized keyword, it's red. It turns green when you spell something correctly. Then press enter, and now you see telnet packets, and there's only 568 telnet packets in here. So the telnet is an old protocol used to send letters to a server without encryption, so you can read them all in the captured packets. So the simplest way to do this, to analyze the telnet packet, is to save it as a separate file first. So you export specified packets, and by default it will only export the 568 displayed packets, and that's what I want. So I'm going to put that on my desktop and call it telnet. And so there it is, telnet.pcap. All right. And so now I'm going to open that one in Wireshark, which I can do just by double-clicking it. And now, if you look here, you can see some data in the raw packets here, but it's really hard to read. There's a little bit of data at the end of each one, like you see Sun OS and stuff. But what's a whole lot better is to use follow TCP stream. So you just right-click the first packet and follow TCP stream. And now you get a nice visible display that just shows you what happened here. What the server sent is in red, and what the user sent is in blue. So there's some preliminary binary stuff that doesn't print out right here. And then you get Sun OS, so he's connecting to a Sun operating system, and now he's logging in. Now notice when he types in the login name, GNOME, every character goes twice. First he sends it in blue, then the server echoes it back in red. So this is GNOME, but when you type your password, the server does not echo it. This is why when you log into a Linux system, it doesn't display your password. So you see it only in blue. So he got in with the password you see here, and then it gave him a welcome message, and then he did an ls-l to see the files, and then some other commands were executed, eventually ending up in an attempt to change password with the password command, but the attempt kept failing because his password, he was unable to succeed in his password. Then he tried to log out, but log out's not the correct command, and eventually he used the correct command of exit to leave. So nothing much happened in this stream, but you can go to the next stream here. That was one telnet session from starting to finish. If you click increment this stream number, you'll see the next session. So in the next session, he tried to log in to Golden, but didn't get in because he had the wrong password. And so on. You can now examine the streams one by one here, and it's very easy to read them. So if you use Wireshark this way, it just presents you nice readable data, so you can just examine it and focus on the evidence and not focus so much on the technical details, just like Autopsy. So there's a few flags to find here. You also want to extract FTP packets the same way and save them in a separate file. And then in your telnet traffic, there's a flag here where you'll find, eventually he makes a message to John. He does cat greater than a file here and creates a file containing data that he's leaving for someone called John to read. And there's a flag defined on that page. So that's the first flag here. And there's FTP traffic. And so let me show you the FTP and the FTP data, because that's another one. So this is just telnet. So when I'm done analyzing telnet, I'm going to analyze FTP. So I'm going to open the original data again, which is here in my downloads folder, case 1, rhino.log. Oh, I probably can't open this. All right, I'm going to have to open Wireshark first because .log is a strange file extension. Wireshark. All right, and there is rhino.log in my recently used files. Okay, so now I want to get FTP. FTP is file transfer, another old system used to transfer things without encryption, and you can read it right here, but again, it's nice to save it as a separate file and use the so export specified packets, and I'm going to put FTP on my desktop. I figure out how to, well, here I'll move to my desktop. Okay. There. Only the displayed 50 packets, so I'll save FTP. All right. And while I'm at it, FTP only contains control traffic. The actual files that are transferred are FTP-data. I'm going to need that one too. So I'm going to export this one too, FTP data. And you see there's 338 of those packets. I'm going to save that too with export specified packets on my desktop. FTP data. All right, now I've got the carved out pieces of this thing I want to examine. So FTP is here, and I can right click, follow TCP stream, and now I can see session. So here he is logging in his GNOME and just opening a binary data connection, transferring a file called rhino1.jpg, and then quitting. And we don't see the transferred file here, we only see the commands that were executed. And so you can go to the various streams here and see what else happened here. He did another file transfer. There's various things that happen here. And there's a flag for you to find, I think. Yeah. The file name of the third file transferred is the flag. All right. And now, if you want to actually get the files that were transferred, you'll find them in the FTP data. So if you go here in FTP data and follow the stream, here you see a file being transferred, and as you hopefully remember from the lecture, this JFIF, now what you're seeing here is a binary file in ASCII format. So you're seeing it as if it was readable, and so the unreadable characters are just these dots, but part of it is readable, like here you see the file written by Adobe Photoshop, and right at the top, near the beginning, you see JFIF, which is the header for a JPEG image. So this is an image file. And you can save it and make it visible. And the way you do that is you change from ASCII format to RAW to save it all. Otherwise, it'll save only the printable part and it won't be openable. So the RAW appears in hexadecimal, and now you just save that with a file name ending in JPG. So I'll put it on my desktop and call it Rhino. I know from the other file that the first one's called Rhino1.jpg. So I save that. It appears here. And if I've done it correctly, that will open in an image viewer. And as you see, it does. It's a viewable image. So that's how you recover images from FTP. And if you go to the different streams here, if you go back to ASCII, this one's an image, that one's an image. One of these is a zip. That one's an image. That one's a zip. Zips start with PK. And you can see that PK contains another image inside it called rhino2.jpg. So you'll have to save this as binary. It's a zip. It's password protected. You'll have to crack the password. And anyway, so that's what you're doing in this one. All good things to practice. So you'll see you find the file name, you extract the images, and find a flag. Then in the FTP data stream, extract the zip archive and crack the password. The password is a common, easy password, so you can use any password cracking utility you like. Like if you've taken 123, you probably know about fcrackzip in Kali. You can also just use an online zip cracker. And once you get in with the right password, then you can find an image in there and find a hash value. So those are a few things to get you started. And probably more fun than watching those videos, but the videos are good for you too. So that's what I wanted to show you. That's the next several weeks worth of projects. I'm going to stop this video.